We're going to look at the tests for the differences of two means. So remember, we always need to have our null hypothesis, which we're assuming the two population means are the same. Our basic formula for figuring out our test statistic is our statistic minus our null hypothesis over our standard error. So in the context of what we're looking at, it's going to be our statistic, which is in the difference of the two means, minus our null. But our null means if these two are the same, you're subtracting two things that end up being equal. So the difference in these two, when you go mu1 minus mu2 is 0. So you go minus 0, so it doesn't change the top. Over the standard error. The standard error is what we had shown you in the last couple of lessons. Now, once again, these will be normal if your population, or not your population, sorry about that, your sample size is 30 or more for each one, and your degrees of freedom is always the smaller of the two sample sizes minus 1. So basically, in this situation, read through it. We're just wondering, does teacher expectation really make a difference in how much students learn and grow? So we have our control group, our sample size, our mean of the control group, and our standard deviation of the sample. We have our growth group, the number in that group, the sample size, our mean of that for the growth, and our standard deviation of the sample. So basically, can we have some causation occurring here where teacher expectation does actually cause students to perform better? So we're going to start off by stating the hypotheses. So once again, there is no difference. We're wondering if teacher expectation for group 1 does make a difference, and they do grow more. This mu1 right here should be a mu2 because that's our control group. So we got to make sure both of our sample sizes are greater than 30, which 65 and 255 are both greater than 30, so that works. So then we got to find our statistic, which is the difference in our two means. So we take the mean of our first group, the growth group, minus the mean of the control group, and we get 3.8. So now we got to calculate our standard error. So we take our standard deviation of the growth group squared over the sample size of the growth group plus standard deviation of the control group over the sample size of the control group, and we get 1.813. So to work this out, we're going to take our statistic minus our null, and that's what we did in step 3. We'll put that on top over our standard error, and that's what we did in step 4. So we take 1.813, put that in the bottom. We divide these two, and we get a test statistic of 2.096. So now we're going to go ahead and calculate our p-value. Our degrees of freedom is always one smaller than your smallest sample size. And because we're looking for greater than, we're looking for the upper tail. And we get a p-value 0.02, and that would come from StatKey. So we would go to StatKey, we would go ahead and hit the t-distribution bottom center. We would enter in our degrees of freedom, which was 64. We had an upper tail, and then we would enter in our test statistic. And we get our p-value being 0.02. So coming back to the PowerPoint, we get the 0.02 from our stat key. So what does that mean in the context of the situation? In other words, what decision should we be made? We have evidence that positive teacher expectation significantly increases IQ scores on average in elementary children.